Hello everyone. This video is about domain and range of the functions. We will be talking about domain and range of 9 different functions. So first let's remember what domain and range are. Domain is the collection of x values that make the function defined. They are the input values, allowable input values. Range is the collection of all y values that we can get as an output. So we can look at domain and range visually and algebraically. Let's take a look at domain and range visually at first. So for example, on the given graph, um, we have to look at the x-axis to get the domain. So on the x-axis, what's the low on the smallest x value? This is the smallest. What's the biggest x value? That point is the biggest. So between smallest and the biggest, we have the domain values. For the range, we will look at the y-axis. On the y-axis, what's the lowest y value? This one is the lowest. What's the highest y value? This one is the highest. So between lowest and highest, we have the range values. Let's look at the question. Exercise 1a. There are two graphs. Let me find domain and range of one of them. For example, function g. So what is domain of function g? So to find the domain, we look at the possible x values. So from the smallest, the point on at most left, this one will be the smallest x value. We will go to the point that's at most right. So this is the lowest, this is the smallest, this is the biggest x value. So between -3 and 3 we have x values. So our graph is between -3 and 3 on the x-axis. Since those 2 points are close, we will close the bracket. To find range, we will be looking at the y-axis. So on the y-axis, what value is the lowest? This is the lowest point on the graph G. So the corresponding y value here is -4. This is the lowest point. I don't have any other graph below -4. The graph starts at -4. So what is the highest point for G? This is the highest point whose corresponding y value is 4. So I don't have any graph of G above 4. Our graph on the y-axis is located between -4 and 4. And since points are close, we are closing the parentheses. Okay, now let's take a look at the domain and range algebraically. We have a bunch of rules. We have rules for every different function. The first of all, domain of polynomial functions. So the domain of all polynomial functions are all real numbers. First of all, let's remember what polynomial function is. Polynomial function is a function that has only non-negative integer powers, like 1, 2, 3, 4, 5. There's no 1 over 2, 2 over 3, or -1, -2. They're just positive integer powers. So every kind of polynomial function has all real numbers domain. Second rule, rational functions. For the rational functions, remember, if the rational function is number over 0, then we know that it is undefined. Denominator can never be 0. So we also know that domain is all allowable x values that we can use as an input. So if denominator is 0, if a number makes denominator 0, it's not part of the domain. We should exclude those numbers that make denominator 0. So domain of rational functions is all real numbers except numbers that make denominator 0. This is pretty simple. We equalize the denominator to 0 and exclude those numbers from all real numbers. For the range, in your book, there is just range of one kind of rational functions are mentioned. if your function is written as number, a constant divided by a linear, if your function is in this form, then your range is all real numbers minus 0. Only this function is mentioned in the book about rationals. So let's start solving questions. 2023 second attempt ministry question, determine the domain and range of the function. So when you look at the options, domain is all same for every option. You don't even have to try to solve domain. Just look at the range then. So what was the range? According to the rule, range is all real numbers except 0 if your function is written in this form. So without solving, without doing anything, your answer is obvious, crying out to be answered. So this is the only option with all real numbers except 0. Why is not 0? If you have the same answers with two same answers with the same domain, then you would look at the domain. You know what domain is? All real numbers except what makes denominator 0. So what makes denominator 0 here? If 2x minus 6 is 0, x is 3. So r minus 3 would be your domain. If they were not all the same, you would solve it like that. Let's move on. So we have such simple questions just solved by I. 2. Another question, find domain. So in order to find domain of rational expressions, we should look at the denominator and exclude the values that make denominator 0. What makes denominator 0? X squared plus 4 is equal to 0. Find x, move 4 to the other side. X squared is negative 4. Is it possible to have a negative result when you square a number? It's never. You can never do this. X squared can never be negative, so that means there is no x value that makes denominator 0. So since there is no excluded value, there is no r minus anything. There is nothing that you need to exclude from the domain. So it is all real numbers. There is no restriction. Everything is possible. No matter what x value you try for x, it will always turn out to be a number other than 0. It will never be 0 because x squared is never negative 4. Another example, find domain. Again, look at the denominator. Our denominator x squared minus 4. X squared is equal to, when you bring 4 to the other side, 4. And x is, take square root of both sides, negative and positive, 2. So when I plug in 2, 2 squared minus 4 makes 0. When I plug in negative 2, negative 2 squared minus 4 is also 0. So those two numbers make denominator 0, which make function undefined. So we should exclude those numbers from the domain. So domain is all real numbers except those that make denominator 0, which are negative 2 and 2. So another rule, I think that's enough for finding domain and range of radicals, rational expressions. Now radical functions. We also have a bunch of rules for rationals, radicals. So let's f of x is a plus or minus square root of x plus and minus b. Then domain is, the radicals. The radicals always have 0 or positive numbers under it. So we need to exclude those numbers that make the radicand negative. The radicand, the stuff on the radical, can never be negative. This is not possible. So we are going to exclude those numbers. So our domain is only limited to 0 to infinity. So we just need to take the stuff written on the radical and set it as greater than or equal to 0. So that stuff on the radical, that radicand, can be 0 or positive, can never be negative. So you take the radicand, set this as greater than or equal to 0. This is not new for you, you already know this. So for the range, you can either sketch the graph. For example, let's say you have 1 plus square root of x. You know how square root functions look like. The square root function is like this. When you have 1 added to the square root of x, you need to move 1 unit up. So that's your function. So its domain is from 0 to infinity. Range is from that number 1 to infinity. So by looking at the graph, you can determine its domain and range. This is a way. Graphing to figure out domain and range is a way. If you think that's hard for you and it's complicated and stuff, you memorize the rules. So according to the rules, the range is the number added from the number added to the positive infinity if the sign in front of radical is positive. If the sign in front of the radical is negative, then this times from negative infinity to that number added. Okay, so apply one of the ways, either graphing or using this method. Exercise 9 in the book, find domain and range. So to find domain, look at the inside, look at the radicand. The stuff on the radical is called radicand. So set radicand greater than or equal to 0. So x is greater than or equal to, bring 3 over negative 3. We can write this as an interval notation. So from negative 3 to positive infinity will be our domain. Negative 3 is included because it's greater than or equal to. About the range, you can graph or apply the rule. We have negative in front, so that means we start from negative infinity until the number that's added to this radical. Which number is added to this radical? Nothing is added, so it's just 0, like this. Ministry question 2021 second attempt. This time the range is given, the corresponding function is asked. Which function has a range from negative infinity to negative 2? So first of all, since you have negative infinity, you need to know that you have negative in front of the radical, right? Look at the rule. When there is negative in front of the radical, it's starting from negative infinity. So you have negative in front. You need to have negative in front of the radical. So not A, not B, C or D. Negative in front of the radical, and it's going to be till negative 2, which means negative 2 is added to the radical, not inside, it's outside. Negative 2 is added outside. Positive 2 is added inside, that's not it. Negative 2 is added outside, yes, that's it. So if you know the rules, you don't need to solve it. You directly know the answer. You can solve the question by eyes. Another question. Find domain and range. For domain, we don't care about the stuff outside of radical. 1 plus has no effect on the domain. So for domain, you just focus on the inside. Just radicand stuff on the radical is important for domain. So on the radical, we just have negative x minus 4. So set this greater than or equal to 0. Negative x, when you bring negative 4 to the other side, greater than or equal to 4. And you can divide or multiply both sides by negative. When you do this, the direction of inequality symbol switched. So x is less than or equal to negative 4. When you write this as interval notation, from negative infinity to negative 4, numbers less than negative 4 on the left side of negative 4, so it's going to negative infinity. For the range, you don't care about the inside for the range. We don't care about the inside. What we care is outside. So there's plus, so we go to positive infinity then. From which number? From the number that's added to radical, which is 1. So 1 to positive infinity. So keep in mind that to find the domain, we focus on the inside. To find the range, we focus on the outside. Domain inside, range outside for the radicals. So this was the first part of radical, the first rule for radicals. The second rule, when there is a quadratic equation, quadratic function, then the domain is quadratic function under radical. So the domain is, for finding the domain, you're going to set the radicand to greater than or equal to 0. Actually, the same rule. The domain, the same rule. To find domain, radicand must be set as greater than or equal to 0. So the only difference is when we solve this inequality, we have different techniques. The techniques that we learned in grade 10. So what are the techniques? For example, find domain of x squared minus 9. So the stuff under radical is x squared minus 9. Set this as greater than or equal to 0. So for quadratics, quadratic inequalities, remember, you were setting this quadratic equation to 0 first, finding the roots, taking square root of both sides. Roots are plus and minus 3. After we find the roots, we were making a table. Some of you will remember this. So we put the smaller number on the left, bigger number on the right. And we were picking a number from each region and checking the sign. For example, pick 4. Bigger than 3, you have 4 in this region. Pick 4 and put it back into the original function. See what the sign is. If x is 4, 4 squared, let me write this. 4 squared minus 9, 19, 16 minus 9 is 7, which is a positive number. Put the sign as positive. Pick a number from the second region between negative 3 and 3, for example 0. 0 squared minus 9 is minus 9, which is a negative number. Put negative. And pick a number from this region too, less than negative 3, let's say negative 4. Negative 4 squared minus 9 is also 7, which is a positive number. So you have positive, negative, positive. So what do you do with these signs? We know that the stuff under radical is bigger than or equal to 0. So negative region is not our region. Only the positive regions are our regions. So we are going to use those two regions only, okay, for the domain, because the domain is, for the domain, we set the inside greater than or equal to 0. So this is where our function is greater than or equal to 0. So for domain is, our domain is from negative infinity till which number? Negative 3. Negative 3 is included. Union, we are going to combine those two regions. When we do this combination, we are using union from 3 to positive infinity. So this is the way of solving domain questions when there's quadratic function under radical. Ministry question 2021 second attempt. Find domain. We don't care about the sign outside. It is just given, this sign is just given to confuse us. So just focus on the inside. Under the radical, we have a quadratic expression. So x squared minus 3x minus 10 is greater than or equal to 0. Since it's quadratic, we need to find the roots by equalizing it to 0 first. So 0 first. So to solve quadratics with 3 terms, we just need to use the factorization. There is no other way. Or either factorization or quadratic formula. I think factorization is easier here. X squared is x and x. 10 is 2 times 5. One of the numbers will take negative since that's negative. Middle term is negative, so bigger number will take negative sign. So you will factorize this as x plus 2 times x minus 5 equals 0. So when x plus 2 is 0, x is minus 2. When x minus 5 is 0, x is 5. So there are two numbers. We make this chart. This is called table of variations. Negative 2 is the smaller one written on the left. 5 is the bigger one written on the right. So now pick a number from each region. Bigger than 5. Pick a number, let's say 6. 6 minus 5 is 1. 6 plus 2 is 8. 8 times 1, 8, which is positive. Pick a number between them, like 0. 0 plus 2, 2. 0 plus minus 5, minus 5, 2 times minus 5 minus 10, which is negative. And pick a number less than negative 2. If you remember, there was a short way. Instead of trying each region one by one, there was a short way. The short way was looking at the sign of the leading coefficient. That's positive. So when that's positive, you start with positive on the right and change the sign for each number. Positive, negative, positive, like that. If there is no double root and stuff. But this is risky. I suggest you to try every region one by one. Okay, what we need is the positive regions, because we set this as greater than or equal to 0. So we just need positive regions. We combine them as negative infinity to negative 2, union from 5 to positive infinity. Okay, you can simply say that when you find the roots, from negative infinity to the smaller root, union from the bigger root to positive infinity. All right, let's solve a question involving composite functions. F composed with g of x, which means this is f of g of x, and that means we take g and put inside f. Take g and put inside f. So that's going to be f of g of x equals square root of g function, which is x squared minus 4x plus 3. Same idea, radicand must be positive, and set the radicand to 0, factorize to solve, to find the roots. The middle term is negative, so the numbers are here must be the negative. X minus 3, x minus 1 is 0, so either x is 3 or 1. So in a short way, you can say from smallest number, smaller number, to from negative infinity to smaller number, union from bigger number to positive infinity. Or make a sign chart, make this table, make the sign chart, and pick the positive regions. When you combine them, you get this domain. All right. That was the second part of this rule, radicand. The third part, this time we have r squared minus x squared, not x squared minus r squared. R squared minus x squared. The order is different. The number minus x squared. So when we have this form, then we have a semicircle. You know what circle is? It's a full round figure. When there's semi, it's half of the circle, like this. So domain of the function is from negative r to r. Let's say this is r, negative r, this is r. Let's say this is the coordinate plane, x, y. This is the origin, this is negative r, this is r, this is r. So domain is from negative r to r, from smallest to biggest x value. Range is 0 to r when the sign of the radical is positive, and it is negative r to 0 when the sign of the radical is negative. Like this. It's still semicircle, but it's upside down. From negative infinite, negative r to r is the domain. Domain doesn't change, but when you put it upside down, the range changes. The range becomes from negative r to r when there is minus in front of the radical. Remember, there is minus in front, then you flip the function. This is reflection. There is reflection around the x-axis. So when you solve these kind of questions, you can make the graph, a quick graph, without memorizing them, find the answer, or apply these rules. Let's take a look at questions. The first question would be exercise 17, and a ministry question. Find domain and range. To find domain, I want to make a graph first. The first number, the number represents r squared. R squared is 9. If r squared is 9, then when you take square root of both, r becomes positive and negative 3. So from negative 3 to 3, we have a semicircle. So by looking at this graph, I can answer the question. So what is the domain? The x values, it's between negative 3 and 3. X inclusive. The range is from 0 to 3 inclusive. So the y values from 0 to 3, x values from negative 3 to 3. You don't have to sketch this, of course. So you can directly say, after you find the r, you can directly say negative r to r, negative 3 to 3, the domain, the range 0 to 3, because the sign in front is positive. Easy peasy. So what is the difference between this 9 minus x squared and x squared minus 9? Are they same? No, they aren't. If there is number minus x squared, then you have a semicircle graph like this. You have x squared minus something, you have a graph like this. Their graphs are different, their meanings are different. So the domain and range are easy for semicircles. That's simple. For the other type, you just need to make a sign chart. Okay. For domain here, it's between those two numbers. Domain of this function is not between those two. Between those two, there is no graph. It's from negative infinity to the smaller one, union, bigger one to positive infinity. All right, one more question. Find domain and range. So, is this which form? Is this number minus x squared form? Is this form or that form? Which form we have here? Determine the form first. Which form we have here? We have the second form or third form? In the second form, we had x squared minus something. This is the second form. Do we have x squared minus something? No, we have negative in front of x squared. So this is r squared minus x squared form, the third form. So it doesn't matter where x is. X can be written in the first place or in the second. We have this form. You can rewrite this as 2 minus x squared. It is the same. Okay, there is commutative property and addition. In addition, you can change the order. It is okay as long as you have negative in front of x squared. Since you have negative in front of x squared, you have the third form. It is a semicircle. This is a semicircle still. So find r squared first. The first number written under radical gives you the r squared. R squared is 2. If r squared is 2, r becomes square root of 2. So the domain is from negative square root of 2 to square root of 2, from negative r to r. The range is, since there's minus in front of the radical, negative square root of 2 to 0, negative r to r. So we are done with this rule 2.